5, the last two questions of quiz 2. Yeah. The first one, question number 9, if a given array does not contain any adjacent inversion, but it must be adjacent inversion, then all the elements in this array must be in place. Here, I use the terminology in place. Actually, it means this array is ordered. Ordered in increasingly ordered. Not decreasingly ordered, increasingly ordered. All right. First, the answer true. Answer is true. If some of you didn't choose the true, then probably you make your decision based on the intuition here. So here, if you only answer this question based on your intuition, you need some knowledge. If only just by your intuition, your real life experience, not enough. The reason is this: adjacent inversion. First, we know the inversion, right? Definition of the inversion. Adjacent inversion, we can call local inversion. All right. Then another possibility of inversion, global inversion, right? So anywhere, any two elements in the array, global inversion. Local, adjacent, All right, so global inversion. These two concepts, All right, so here, then if you only use some kind of logic, sometimes people answer the question based on the intuition and logic. Another thing other than intuition, the logical reasoning, logic. All right, adding together. So here, they use this kind of logic. If a given array does not contain any adjacent inversion, but it can contain some global inversion, right? If you just use the general logic, not just logic, the general logic. All right, general logic. Then you may do the logical reasoning in this way. It may contain some global inversions. Then you cannot say all the elements in this array must be in place. But here, there is a very important property. Because if you just use logic, you didn't pay attention to there is important property here we need to use. Property. All right. The property is, a property is if an array is unordered. Ordered. Ordered, right. Then it must contain and adjacent inversion. Okay, yeah, adjacent inversion. This property is the foundation of the bubble sort. Yeah. Why the bubble sort is correct, right? Why the bubble sort is correct? Because of this property. Yeah. Adjacent inversion. Yeah. Although if you put a global inversion, it is also correct. Yeah. But a global inversion will result in an adjacent inversion. If an array contains a global inversion, then it must also contain an adjacent inversion. Yeah. Because using some transitivity property, right? Transitivity property. Here, let me write it this way. Yeah. All right, yeah. A global inversion implies a local inversion by transitivity property. Transitivity property. Yeah. 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 All right. Yeah. Yeah. All right. So that is the background of this question. Yeah. So you have to know a little more than just intuition and the general logic. What more? Yeah. Some critical properties. Critical properties. Yeah. All right. Yeah. The last question, question number 10. An exponential function with base greater than 1. Yeah. So we represent it as a to the nth. This function with a greater than 1. Yeah. Has higher order of growth than that of any polynomial function. Polynomial and to certain number of, degree k, all right? Yeah, polynomial leading term. So here, let us consider leading term, yeah, because the remaining term, yeah, less important. Leading term, dominant. All the other terms. Yeah. So it's good enough to only consider the leading term. Yeah. All right. Yeah. Then exponential function dominates any polynomial function. We have that result. Yeah. That result we did as an exercise quest, as an example, yeah, using L'Hopital's rule. Yeah. I remember something like this. N to the d, yeah, that limit is infinity. That limit is infinity. Yeah. This we can treat as the leading term. The leading term. Yeah. All right. All right. Yeah. So the answer true. Yeah. All right. So that's all the 10 questions of quiz 2. Yeah. All right. Yeah. Let's stop here. Yeah.